All right, good morning. So, welcome back to statistics. We are going to tackle section 3.3 today. Okay, this should be kind of a faster chapter than the last one, but actually, I'm lying to you because there are a number of problems. They require you to sort the data because every time they're going to ask you for a median, every time they're going to ask you for a quartile, every time they're going to ask you for, anything like that, we have to put the data in order. Okay, so that's going to be a thing that we're going to have to do is put them in order. Now, in a face-to-face class, I would usually order the data for you because I know good and well that you know that 12 is a bigger number than 8. Okay, but the way that they pitch you the problems in ALEKS is they just jumble the data, they put it in whatever order they feel is appropriate, and they say for you, here, go ahead and sort it. Okay, so I'll try to pause the videos when I do that because you guys don't need to watch me put the data in order. But the reason why this can take a long time is because we're going to have to put everything in order when we do it. Okay, so we talk about data today, we talk about everything today. I'll share my screen. Okay, so what we're going to be talking about, okay, is we're going to be dealing with pretty much three topics. We're going to be dealing with measures of position. Okay, this is my pen. Okay, measures of position. So we have measures of position. Now they're going to go with z-scores. Remember, this is a formula you have to memorize. Okay, so z is equal to x minus mu divided by sigma. Okay, there's actually another one. It's x minus x bar divided by s. Okay, that would be a t-score, and they're slightly different because remember the standard deviation, population standard deviation, and sample standard deviation are two different values. Okay, so I don't think they make that much of a distinction in this book. So when they say z-score, they usually are going to hand you everything, but this is what they're talking about. Okay, they're going to talk about the empirical rule. Okay, so remember, if it's within plus or minus one standard deviation, then that's 68% of your data. Plus or minus two standard deviations, that is 95% of your data. Plus or minus three standard deviations, that is 99.7%. This is almost all. Okay, so they're going to ask us about empirical rule. We have to remember this rule. Okay, so we have to remember z-score. We have to remember this rule. The other thing to consider is that empirical rule only applies to bell-shaped. Okay, you can think of with, I don't know, if you guys make Christmas cookies or anything like that. There's like little Christmas cookie cutters. They want the bell. Okay, that's what they're talking about. This terminology was done 19th century. Okay, so we're talking about 1800s, maybe, or not 19th century, yes, 18th century, so 1700s. So think about like Liberty Bell type of thing. That was very important. So bells were a very important part of people's lives then. So that's why bell shaped was done because when this was coming up, they were like, oh, it looks like a bell. Mound would work. Okay, so you can use other shapes that have more meaning to your life. But when this was invented, it was very, bells were very important. Okay, so for me, the only bells that I see are Christmas cookies. That's it. Okay, so we have measures of position, z-scores, plus or minus, this is our formula for z-score. We have empirical rule, okay, plus or minus 1 is 68%, plus or minus 2, 95%, plus or minus 3 standard deviations, almost all. The z-score is your key to unlocking. That's just how many standard deviations away from the mean we are. Okay, so that's what we're going to be dealing with here. Okay, so that's kind of the z-score is the key to unlocking your empirical rule here. Okay, and we'll go through and do some of that. Right. The other big method, the other big topic in this section is as percentiles, or more importantly, quartiles. So we have the 25th percentile, which is the quartile 1, Q1. That is 0.25 times the number of things in your list. And that gives you a number they call L. Okay. And they say if L is a decimal. Okay. So it's not a whole number. Like, what if I do 0.25 times 11, right? That's not going to be that's going to be a fraction. It's going to be a number with a decimal to it. okay, times 11. Okay, we get 2.75. So this is not the value. Okay, this is not the value of our quartile. This is the, excuse me, this is the location of the quartile in the list. We want the 2.75 thing. So if it's not a whole number, we boost it. They say round. I'm going to say boost because I don't want you to look at that and say, well, if it's 0.5 or above, then no, that rule doesn't matter. We boost it to the next individual thing. So we're going to take whatever's in the third position. Okay, and again, we ordered and sorted the data. So whatever's in the third position, that's going to be our first quartile. It's going to be Q1. Same thing, Q2, that's the 50th percentile. You guys have already seen the 50th percentile. We call it the median. The same rules apply. Okay, we take 0.5 times n. Okay, if it turns out to be a fraction, okay, so if the number is odd, so it's like it's 0.5, say I had 21 things, okay, we're going to say 0.5 times 21, okay, we're going to get 10.5 here, so we have 10.5, so the L number is going to be 10.5. Since it's not a whole number, we're going to boost it. We want the 11th thing in your list. Okay. That's how we get that's where we're doing the medians in this section. Okay. So I don't want you to type everything into your calculator and say, press descriptive statistics and figure it out, because sometimes these problems get a little long, and it's easier just to go through what the list is and get that value. Now, what if I do, and we have, what if we get a whole number? Okay, so what if I'm doing Q1 and I want 0.25 times, and I say I have 40 things. Okay, we're going to say 0.25 times 40, right? So 0.14 times 40, we should get 10. So 0.25 times 40. Okay, and we just get 10. So the L number, the position you're looking for, the position, not the value, the position is the 10. What we have to do is we have to take whatever happens to be in the 10th position and 11th position and average those together. And that is going to be, whatever numbers between them is going to be our first quartile. Okay, we'll get to the examples. I think it'll make a little bit more sense. Okay, but if you get a nice whole number here, it's like, oh, the work has just begun. Okay, if you get something you can round or something you can boost, like that's much better. But this is usually going to be a number that you're going to be able to average two numbers around it. Okay, and that's what we deal with quartiles. Okay, and then the last thing we have to deal with has to do with quartiles is something called the IQR. Okay, this is called the interquartile range. Okay, and this is another formula you probably have to memorize. That's Q3 minus Q1. Okay, so whatever we found in quartile 3 minus whatever we found in quartile 1, and that's going to be our value there. Okay, so that's pretty much an overview of what we're going to be covering in this chapter. It's not, it seems like it's a lot to memorize. It seems it's a lot to remember right now because I'm throwing it at you all at once. It's really not quite so bad. And as we start working through the problems, you're going to see, oh, this isn't too bad. The hardest part of this is just putting everything in order. Okay, that really is the most tedious part about this chapter, and that's why it's going to take a long time. And I'm sorry for that. Other chapters that don't have us do this, okay, so chapter 2 was hard because we have to do graphical display of data, we have to put things in order. Chapter 3 is hard because they're asking us for medians, they're asking us for quartiles, we have to put things in order. The rest of the class doesn't tend to be quite so tedious as far as putting things in order and having us sort things. So it does tend to go a little bit faster. So if you're going through this and like, wow, this takes a long time to do this homework. It's not that it's hard, it's tedious. Okay, and that's the difference. Okay, tedious just means like if I would rather not do this because it's just going to take a long time. It's like cleaning a room or something. It just takes a while. But it's not, they're not particularly hard problems. It's just, okay, I've got to put things in order, I've got to keep track of everything, and then we've got to come back and remember what the problem was asking for. The rest of the class tends to go a little bit better. Okay. a little bit faster. We don't have as much tedious stuff to deal with. Okay, a lot of the calculators do a lot of the heavy lifting. So I'm going to stop us there to kind of give us, here's our intro to 3.3. Okay, so remember the three things to remember. Okay, we have z-score. You have to remember what that is. Z equals x minus mu divided by sigma. This tells you how many standard deviations away from the mean you are. And if you say, well, that's kind of a weird thing, I don't know if I can remember that. You are not alone. Okay, this is the hardest part that most students have trouble with. Okay, it's like remembering what a z-score is. Okay, it's the number of standard deviations away from the mean. Every time we do that, I will say those words. Hopefully that'll start to stick. But if it takes you a little while, you are not alone. This is normal for everybody who learns this. Okay, so we have z-scores. Okay, it tells you the number of standard deviations away. I'm going to give you one little addendum for this. If it's more than plus or minus 3, okay, so if it's more than 3 z-scores, 3 standard deviations away, less than 3 standard deviations away, we usually call those unusual observations. Sometimes we'll call those outliers. I really hate to call them outliers because some of the more fancier techniques have a requirement to say no outliers. People are tempted to just throw that stuff away, and you can't do that. Okay, you may have remembered over the past summer of 2022, the governor of Mississippi said, "Okay, well, we have a terrible maternal mortality problem here, but if we just remove, black people from the population that we're studying, then it comes in line with everything else." Like, well, newsflash, no, it doesn't. But you can't just remove, like, it's not unusual that you would have a black person that is mother, okay, black mother. So you're not allowed to, like, remove outliers. If you're going to remove them, it has to be for a good reason. Like, it's an unusual observation. The example I usually give is, like, the first pancake I make comes out terribly. The rest of the pancakes I make in that batch come out beautiful. I'm a very good pancake maker. But the first one is a mess. Okay, you can't just take everybody of a certain ethnicity and say, well, we're going to remove those from the population because it's inconvenient. You're not allowed to do that. Okay, so when somebody says, hey, let's just take out all the outliers, make sure that you know what the reason is that you're removing them. Okay, plus or minus 3, it's unusual observation, sometimes called outlier. That's the cutoff for, like, is it unusual? Okay, plus or minus 3. So the second thing, so first thing, z-scores. Second thing, empirical rule. Okay, plus or minus 1 standard deviation, we have 68%. Plus or minus 2 standard deviations, we have 95%. Plus or minus 3 standard deviations, we have almost all, that's 99.7%. I'm sorry you have to memorize those, that's just a thing, but it really will help your being able to estimate, like, how likely something is going to happen. And as humans, we are terrible at this. So I don't want you to think, oh, I'm never going to memorize it. You will. You can. Okay, I believe you. I believe in you. You can do this. Okay, but it tells us, like, well, it happens within plus or minus 3 standard deviations. I'm like, I'm not that worried. This is almost everything. If it happens outside of that, right, plus or minus 3 z-score, then it's like that only happens to 0.2%. That's 2 in 1,000 times it happens. So then it's like, well, that's unusual. Okay, so of all the pancakes I make, 2 in 1,000 don't turn out so well. That's pretty good. Okay, and since a batch is usually about a dozen, I'll just say, that's an optimistic ratio for me. Okay, so that's empirical rule, and then we have quartiles. Okay, and the hardest thing for quartiles. Okay, there's a couple of different rules we have to worry about with that, but again, a little bit of practice will pick it up. We're just going to take 0.25 times n. That's going to give us our L. If our L is a whole number, or is a fraction, there's a decimal to it, then we just boost it. That's the easiest case. If L is a whole number, we've got to average the L and the next one up. Okay, so we're going to, so it's whole number. Okay, then we have to average these. Okay, and we're going to have our quartiles. Okay, so hopefully that was a reasonable overview of this section, but that's all we're responsible for. So we have z-scores, we have empirical rule, and we have quartiles. The most tedious and the thing that's going to take you the longest is putting this data that they're going to deal us into numerical order. That's the first thing. You got to put it in order for us to work the problem. Okay, so hopefully it won't be too bad. I'm going to go ahead and stop the video so that we can get a fresh start on getting through our homework, and I'll go through and do a walkthrough. Okay, see you in a minute.